Utter chaos. Yep. Of course I can. Oh, all right. All right, I think people should be making their way in here in just the next few minutes. Good, 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 good. Okay. Howdy again. I'm glad to see people are making their way in. Sorry I was a little late getting that link posted this morning. Just now, rather. It's first day of the term, things are always a little bit chaotic, and then of course Zoom had that nationwide outage this morning, which made things extra exciting and crazy. But it looks like folks are finding their way here. That's good. In just a little bit, I'll give a few more minutes for people to get in. We will go ahead and get started. For now, let's do it like this. This is MAC 1140, section 004. And today is 8/24. So today we're going to do a few things. We're going to go over the syllabus. And talk about webassign. And textbook options. We're going to talk about office hours. That's it. And then we're going to get into a little bit of math. I think probably section 2.1 is where we begin. What if I start on there? So how are we doing here? We got most everybody in. Yeah, it looks like we've gotten there. 10 participants up there. I'll give just another second or two for folks to get in since I was late posting that link. Still at 17. Fresh email components. Oh, okay. Oh. All right. So then I think most of us are here now. We can go ahead and get started. Go back to my screen share. All right, this is what we're going to do today. And this is pretty much what you'll see every day. Most of the work here will be on the .cam. I'll show you things in Desmos and stuff like that. But think of the .cam here as being like the board in a big class. So pretty much anything that you see written down here, you should be writing in your notes also. And you want to try to keep your notes nice and organized. I suggest like a date and a heading of some sort, a little outline of what we're planning on talking about, and then the actual content. But try to take good notes, try to keep them nice and organized. That will go a long, long way for this class. First thing I want to do today is go over this. And then we'll talk a little bit about webassign in case you haven't used that before, how to get in, what you need to do, your different textbook options. Since this is a webassign class, you'll have access to an electronic text through webassign, but there are other options for textbooks if you want them. We'll try to set up some office hours that work for everybody, and then we'll get into the good stuff. So first, the syllabus. If you come to our class here in Canvas, you go to the home page. The home page is the syllabus page, but this is not the full syllabus. This is kind of just a few little basic things. To view the full syllabus, you have to click this second link. So if you haven't done, I would recommend clicking that link and then save this file to your computer. My suggestion would be on your desktop to have a folder for this semester, and then within that to have a folder for this class. So I'll go ahead and make mine now, MAC1140.004. And that way you can put all the different things that I ask you to download, save, read, whatever, into a place where you can find them. So I'll save my copy there, and then we can start going through it. Another little comment here is if right now your computer has its default PDF app set to a browser, like Chrome or Edge or Firefox or whatever you're using, Safari, I recommend changing that to a dedicated PDF software. Like I use Sumatra PDF, it's really good. Adobe has one, it's just a little bit cluttered, but you see everything renders very well when you open it in a browser. But if you open it in off of your computer in a PDF viewer, it will render nice and pretty. So this is the syllabus for our class. Hopefully we know these things, MAC1140, pre-calc, fall, section 4. This is my name, John File Sticker. You can call me John or Professor P or whatever you want. If you're worried about pronouncing this, it's File Sticker, like a filing cabinet with a sticker on it. And I'm an assistant professor here at Santa Fe, which means I don't have tenure yet. But I've been at Santa Fe for about 4 years now. Before that, I taught at UF for about 2.5, 3 years. And then before that, I was at UCF for a few years. So it's been a fun road. I like teaching math. It's good stuff. My physical office is A031D on the main campus, which is the Northwest campus. This is downstairs and the north side of building A in what's called Unit 2. Right now, I'm not allowed to hold any actual in-person office hours, but that might be changing. So as the semester goes on, this might be worthwhile information. Email is definitely the best way to get a hold of me. If you need to talk to me, ask me a question, anything really, send an email to this email address, or you can use a Canvas message. Canvas messages automatically get forwarded to my email. Class meetings, we figured that out because we're here. They're Monday and Wednesday from 2 to 3:15. And the Zoom links will change. I'll post a new link for every meeting. For security reasons, we don't want to use a standing link. So check the announcements every day right around 2 p.m. To find that day's link. Office hours is something we need to talk about. I'm going to go back to that after we finish going over the syllabus and a few other things. But basically, there will be 2 types of office hours. There will be like scheduled drop-in office hours. And I'll have 3, 4, maybe 5 of those per week. And then separate from those, if you want to talk at some other time, or you want to talk one-on-one, or you're worried about grades or something you don't want to have other people in the room for, you can schedule an appointment office hour whenever you like. And that's not like me doing you a favor, that's a regular thing. So you don't be uncomfortable at all about asking for an appointment office hour, just a regular part of the job. I'm happy to do it. So yeah, those are those. We'll set up again the specific times for these through this week. I want to coordinate among all my classes and make sure everybody can come to as many as possible. The final exam, you want to put this in your phone right now, is December 7th from 3:30 to 5:30. I would put that in my phone with like a 2-day alarm, a 1-day alarm, and like a 1-hour alarm or something like that. You really don't want to miss this time window because there's not a lot of opportunity to make up the final because it's right at the end. Prereqs for this class, everybody knows, you can finish them. The textbook, we're going to use a book by Stewart called Pre-Calculus, Mathematics for Calculus. It's in its 7th edition, and the ISBN right now is this. I have a physical copy downstairs. I suppose I should grab that so you can see what it looks like.
So,
Okay. So the textbook looks like this. Yours won't have the little red bar at the bottom, but if you want a physical copy of the text, you're curious what the text looks like, that is it. And we'll talk a little bit about other textbook options when we get into the webassign stuff. Webassign, so other things you'll need. Basically, the webassign access code is what more or less replaces the textbook, because once you get into the webassign class, you'll have access to an electronic copy of the text there. So in order to get into webassign, you will come here and you can click this link or just go to webassign.net. You click here to enter class key. And then the class key you need to enter is this. If you already have a webassign account from a previous course, you can log in instead of going to enter class key. Either way, at some point, you will be asked for a class key to register for a particular class, and you'll type those things in here. After you go through that, it'll ask you for your access code. If you haven't purchased an access code yet, you can scroll down to the bottom of that page and select the option to use a temporary access or trial period, however they word it. It's 2 weeks. So you can be enrolled in our class in webassign without having purchased an access code for 2 weeks. But after 2 weeks, it'll kick you out unless you've bought an access code. So you do need at some point in the next couple weeks to cough up somewhere between $80 and $100 for this access code. Once you're in there, so I'll go back here and log in. Once you are in, here is our class. You can click here to get to the ebook. I'm personally not crazy about the way the ebooks are organized. I find they load a little bit slow, they're a little bit clunky, but overall they're okay. And it definitely has everything the textbook has and a little bit more. It's got lots of extra videos and things like that that might be useful if you're very patient or if you enjoy this format, that's good. If you are looking for a hard copy of the textbook, I recommend looking at abebooks.com. And you can search around in here. You could actually search this ISBN. And see what we find. So most of these are still pretty pricey. Maybe if we search this, we can find some used results. We want Stewart. Yeah, so you can find some slightly less expensive international editions, things like that. But you do have access to the soft copy through webassign. So the big thing is getting you into webassign. All of the homework and quizzes for the class will be in webassign. And you will have homework starting this week, starting right away. So whether you have your access code or not, it's imperative that you get into WebAssign, go ahead and register using this class key. If you have your access code, go ahead and put that in. If you don't, then use the trial access, but get in there right away. I would like it if everybody is into WebAssign today. Definitely need to be in there by Wednesday. Your first homework, we'll talk about in a minute, is going to be due next Monday. Calculators, so you don't need a calculator in this class. I know a lot of people feel uncomfortable without a calculator. So if you insist on using one, this is the department approved calculator for the class, the TI-32XS. That one you can use on tests, you can use wherever, that's fine. But no graphing calculators, no calculators like the TI Inspire that can do symbolic manipulation, none of that stuff is allowed. So in this class, you're learning to graph by hand. All of those sort of things we need to get comfy with. The other thing you'll need is a computer. You're all here, so you all have some sort of computing device. Got to have a browser that's kept up to date. Got to have consistent internet access, especially for the exams, which will be proctored using HonorLock. If you lose web access during one of those, HonorLock will boot you out and you'll have to get back in. And similarly, you need a working webcam for the same reason. HonorLock requires you to have a fairly high-res webcam so you can get a good picture of your ID and they can keep track of what's going on in the room. The description of this class, basically this is the algebra you need for calculus. And that makes sense. So this class, together with trigonometry, is meant to get you ready for Calc 1. We're going to study functions, specifically polynomial functions, rational functions, different kind of algebraic functions, so stuff like polynomials, but maybe with some square roots, or rational functions, maybe with some cube roots. We're going to talk about logs, exponentials, and piecewise combinations of any of these types. So how to glue these sort of things together as piecewise functions. There's a strong emphasis on graphing. We care very much about you being able to draw the graphs by yourself. And then we're going to talk a little bit about conic sections. We'll talk about nonlinear inequalities, systems of equations, matrices, determinants, all sorts of good stuff. If you want a full list of the topics that the course is covering here at Santa Fe, you can click that link and it will take you to the outline page here. Cell phones, not as important in the online setting, but just don't be a jerk, don't distract people. And absolutely no phones or smart thingies on exams. Attendance, I'll be using Zoom to take attendance. You don't have to do anything. I do ask that you use your real name in Zoom because that's how I know who you are for attendance purposes. And that's all. There is no attendance component to the grade. If you miss a class, you don't have to worry about coming up with an excuse or telling me why. It's okay, life is life, we're all grown-ups. But try not to miss classes, right? It's highly recommended that you attend every single lecture. Missing a class can be devastating, you know, because we build every time on what we did last time. I do record all of these lectures and the recordings will be made available online. So if you miss a class, it's not the end of the world, but watching the video is not the same as being here to participate in the discussion. So I ask a lot of questions, I expect a lot of responses and feedback, and I want you guys to be thinking along with me. And the best way to do that is to just come to class on time. Makeups, I'm pretty loose about this stuff. If you are late on a homework, that's fine. You can just submit an extension request and I always grant those. There's no penalty. There are other things like quizzes and study guides that I'm a little bit more reluctant to move due dates around for, but just communicate with me and let me know what's going on. If it's reasonable, then I'll work with you. I'll always work with you as much as I can. Exams are a big deal though. If you miss a test or if you are going to miss a test and you know it, you need to let me know ahead of time and we can make arrangements. If you miss a test without having let me know ahead of time, I'll still work with you and get you a makeup, but the makeup has to be scheduled within a week. You gotta tell me what the hell happened and please just be honest. And know that the makeup exams are always harder than the original exams. So if you're going to miss a test, let me know ahead of time. And if you happen to miss a test due to whatever circumstances, just communicate with me as soon as you can, like this is what happened, I missed this test, let's get the makeup sorted. And I'll work with you. You know, I just want to see what you know. I'm not trying to drive anybody crazy. Homework, there's quite a bit of homework in this class and it's all in WebAssign. So Monday of each week, I'll open that week's homework. We'll talk about that shit in lecture, and you guys will work on that shit in the homework. And then Monday, the following week, right at the start of class, is when the homework is due. So you can work on the previous week's homework all the way up to Monday of the next week. There are going to be quizzes in webassign also. So every time we meet kind of a milestone where we've talked about a handful of things that kind of work together, I'll put together a little quiz on there. You'll have 3 attempts at each quiz. And remember to just be honest. They're not proctored or anything, but cheating on a quiz is a silly thing to do, because the quizzes are my best way to measure how you're learning the material, and the feedback I give you will be based on how well you do on specific questions and specific quizzes. So please let the quizzes be an honest reflection of your ability. Take your time with them. You got 3 shots, so there's no reason to worry about the grade. Just take your time, go slow, start early, give yourself plenty of time to work through all the stuff, and you'll be all right. We're going to have 4 regular tests and 1 final. So through the semester, 4 midterm exams, and then during finals week at the end, there will be 1 cumulative final. The midterms are going to be during our normal class time. So on the day of a test, instead of coming here to a Zoom meeting, you will go into Honor Lock in Canvas, and that will navigate you to the test. And then the final is going to be again on the 7th of December from 3:30 to 5:30. And yeah, all this stuff is going to be, right now because of COVID, we're doing everything online. So it's all in Canvas, it's all proctored by Honor Lock. A little warning, I do record all of these meetings, and then for anybody who misses them or wants to review them, I post them to YouTube. So just be aware of that, right? If you don't want to show up in the recording, you can always do like Gabrielle has done here, and have something other than your face, or turn your video feed off, or whatever you want. I spend most of the time in the screen sharing mode on the dot cam, so you don't have to worry about people being able to see anything in detail, but just be aware that you might show up in that little window on the right. Some important dates, these should all go in your phone right now, I guess with the exception of this one because that's today, but all the rest of these I would put in your phone. These are things that you want to know, you want to be warned about ahead of time. So if you decide that you definitely don't want to take pre-calculus this semester, the last day to bounce out of this class and get your money back without anything on your transcript is this Friday, the 28th. The last day to bail on this class and get a W rather than an A through F letter grade is Halloween. There are 2 holidays here, Labor Day and Veterans Day, and then also the Thanksgiving break. It's worth noting that the 26th is Thanksgiving. So the Wednesday before Thanksgiving, we still have class. So Thanksgiving break, I don't think will actually affect us because we don't have meetings on Friday, but it's in here anyway. And then the last regular day of class is December 4th. The final exam is the 7th, and grades will be posted by December 13th. So I would put all of these along with the final exam in your phone with a little notice or warning or whatever. The grades. So the homework altogether is worth 150 points, or about 18% of the grade. The quizzes in webassign are worth 100 points, or about 12% of the grade. The midterms are worth about half of the grade altogether, about 48% cumulatively, or about 12% each. And then the final exam is worth about 1/5 of the grade, about 21%. So the total possible points you can earn if you like to keep track of things in points is 825. And then I've got the grading scale breakdown here. So it's the normal 90 to 100 is an A, 87 to 90, that's a B plus, right? So that's the basics, right? Standard grading scale, and I've got the point breakdown here if you want it. But you'll always be able to track your grade through Canvas. I'll always be using the Canvas gradebook. You can always go in there and enter your what if scores and play around with them. Just make sure you're entering points that make sense. So if it's a 150 point assignment and you get 100% on it, that's 150 points, not 100 points, that sort of thing. The next page of the syllabus is standard like Santa Fe boilerplate stuff. There's something called the GELO, General Education Learning Outcomes, that we track through exams. These will be a few particular questions. You won't know which ones on the tests. Or we send the statistics off to the state. Doesn't have any effect on your grade, doesn't show up anywhere in your transcript, not something you need to worry about. Academic integrity is a big deal, especially with everything being online right now. I know how tempting it can be to, I don't want to use the word cheat, but cheat. And how tempting it can be to misrepresent yourself online. And more so than it is in an in-person class. I'll just say these few things, right? I hate having to do like conduct trials, but I totally will if I have to, if you know, if I see things that are going to devalue your degrees taking place, then I really don't have a choice. I have to report it to Dan Rodkin and start a conduct trial. I hate doing that, but I will do it. And please just be honest with me. You know, if you're getting ready for exam 2 and you're like, I am so fucked, there's no way I can do this. I haven't gotten the homework done. I'm not ready. Like, I'm gonna fail unless I cheat. Put that in an email and send it to me, and I'll work with you. I really will, as much as I can. You'd be surprised. We can be flexible. I would rather end up with an incomplete at the end of the semester and give you a few weeks to round up the last little bits of material than you cheat and us have to go through that whole conduct board process. So really, really, be honest and show me what you know. Represent where you are realistically when you speak to me, and I will work with you. I will meet you wherever you are and work to get you over whatever hurdle you're at. So please don't bullshit me. That's all. Don't bullshit me. I won't bullshit you. I promise I'll work with you. I want to do everything I can to discourage you feeling like you need to cheat because you don't. I promise you can get through this. American with Disability Acts, the ADA. So if you have a disability, if you're registered with the DRC, or even if you're not registered with the DRC, but you're thinking about it, or you might qualify for testing accommodations, anything like that, reach out to them. They're awesome. The DRC is great. Karma's wonderful. Also reach out to me because I gotta know. They will tell me a little bit, but you gotta tell me the rest, especially with alternative testing contracts right now. Because of the way everything is online, we have to decide whether you want to do Zoom with the DRC or you want to do Honor Lock with me. We can meet your accommodations either way. But if that's the case, if you are registered with the DRC or you're thinking about registering with the DRC, if you have accommodations or you think you'll have accommodations, in addition to talking to them, please talk to me also so we can make sure everything gets squared away. Accessibility is kind of a continuation of the ADA thing, but if for whatever reason you need like a screen reader or a note taker or anything like that, let the DRC know and also let me know. The DRC will work with you and then I can talk with them and come up with a solution that works best for everybody. Discrimination and harassment. I hate that I have to say this, but please don't be an asshole. Just be decent to each other, be decent to me, be decent to staff on campus. In general, just be decent. The specific rules that you're expected to follow are here. And similar to the academic integrity stuff, I would really recommend reading these because when people do get into trouble, those are the rules by which they are judged. So it's important that you know those rules. Similarly here, student rights and responsibilities. You should know these also. You should be aware of the sort of things that the college expects of you and the sort of things that can get you in trouble, just so you can stay away from them. And then the last bit of the syllabus is an outline, what we're going to do and when. Let's see, is this the new one? Do we actually end on the 6th? We don't end on the 6th. We end on the 4th. 12/4, 12/6. So this should be 12/30 to 12/4. We've got an extra week in here. Yeah, so scratch this off. You don't need this. We'll stick a little bit of the binomial theorem up here because we don't actually have 16 weeks. I don't know how that got past me. Sometimes when you're editing these things per semester, it gets a little sloppy. But yeah, so this is approximately what we're going to cover and when. This first week, we're going to talk about functions and graphs. Next week, we're going to talk about how to get info from the graph of a function, like where is the function increasing? Where is it decreasing? What's the domain? What's the range? All of that good stuff. And we'll just be plowing through these topics at about this pace. So that's the syllabus. Any questions for me from this stuff? Take a look and make sure everything's calm in the chat. Okay. So then I do want to come back to webassign really quick. Any questions for me about how to get into webassign? Questions about access codes, questions about the class key, anything like that?
Yes, sir. I logged on to webassign the other day, and I signed up for this class. I used the key for this class. I just didn't purchase the access code. Where exactly do you navigate to get to that on there? Is it just like the bottom of the screen or something?
So
Or
you can buy an access code direct from Cengage, direct from the publisher. I'm not 100% sure where you go to do that. And you can also buy them through the Santa Fe bookstore, but that might be more expensive. So
okay. And I have to purchase it in order to use the webassign for like the homework and everything.
once you're registered for our class in WebAssign with that class key, even if you don't have an access code, you'll be able to get into the homework and stuff. But
Okay.
after 2 weeks, it's going to kick you out unless you buy the access code. So you do need to buy the access code in order to do the homework and stuff, but you can start right now, even if you haven't. Think of it as a free trial.
Okay. All right. Thank you.
And then it looks like subscription. If you want to buy the stuff from them online, you can go to dashboard of repurchase options, buy individually. Their help is never actually that helpful. I'm not 100% sure where you can grab it in there, and the trial period is 14 days. Yeah, 2 weeks. Okay, but I would shop around, talk with other people, talk with other students, see where they're buying their access codes. It seems like every semester, the cheapest place to get it changes a little bit. Sometimes it's Amazon, sometimes it's straight from Cengage, sometimes it's the bookstore, and I'm not sure which is the case right now. Okay. Any other questions about syllabus, webassign, textbook? No? Okay. So then office hours are next. So this is what my schedule is looking like right now. I'm planning to do the bright yellow office hours. These are ones I'm definitely going to do. And these will be standing, regular drop-in office hours. And then the less bright yellow, these are ones I'm thinking about adding to accommodate folks who can't make the bright yellow ones. So the first thing I would like to do is have everybody take a look at their own schedule and then look at these bright yellow office hours and let me know, is there anybody who cannot make at least one of these bright yellow hours per week? Is there anybody that can't attend at least one of these per week? Anyone who's busy during all 4 of those bright yellow times? If so, please let me know. And in chat, tell me a couple hours you could add that would work. So if you can't make any of these bright yellow ones, but this Tuesday 8 to 9, oh, that should be AM, works for you, let me know. I'm probably not going to add all of these dark yellow ones, just 1 or 2. So first, is there anybody that cannot make at least one of these 4 bright yellows? And if not, that's awesome, but I assume that there's probably at least one person who can't make some of those. No, is everybody good?
I can only make it on Friday.
So this one works for you, but the others do not?
No, only on Tuesday in the morning, 8 from 9,
Oh, so this is the only one that works for you.
and Friday.
And which Friday?
Yeah. From
So
2 to 3.
the 2 to 3 works? Okay. Is there anybody else in a situation like that can only make one of them?
I think the one that you just clicked, the 2 to 3, is one that I can make.
This one would be okay?
Yeah.
Okay, but none of the others?
I'm still trying to figure out my schedule and like the different times.
Okay.
That would work. I'll email you when I know.
That sounds good, yeah. All right, so for right now, I'm going to plan to have these as standing drop-in office hours. And to get to those, you will come to our Canvas page here, and I'll have a Zoom link right here that you can click. So during one of those hours, if you want to come in and talk about problems or whatever, just come to our Canvas page, click the link next to office hours. I'll update this with those 4 times. And then if you want to meet outside of that, you can always just make an appointment with me. Okay. So then, I think we're ready to talk about a little bit of mathematics. So the place we begin in this class is talking about functions. Let me see. Oh, that's right. I don't have an electronic copy of your text. All right. But before we talk about functions, I think it's wise to talk a little bit about the real numbers. So a primer for chapter 2. Real numbers. So the real numbers turn out to be a somewhat strange place. There was a time when their existence even was controversial. People are like, I don't know if the set of real numbers exists or makes sense. We didn't have a rigorous definition. But the basic definition, the real numbers can be thought of as all possible distances. Measured positively and negatively. They can be arranged on a line. With values ascending or going up to the right. So, here's the picture we're all used to. Maybe 0 is right here. And anything that's to the right of 0, I would call bigger than 0. Anything that's to the left of 0, I would call smaller than 0. The main kind of surprising or interesting thing about the real numbers is that the line has no gaps. So you could chop wherever you want. If you chop right here, you'll always find a number right where you chop. Right? No gaps, no holes. Or in other words, if you threw an infinitely fine dart at the number line, no matter where that dart lands, you're always going to have a number. There's no missing bits. So, maybe 1 is like right here, and maybe the square root of 2 is like right here. Pi is somewhere out here. And the reals are made up of not just all the whole numbers, and not just all the fractions, but also all of the irrational numbers like √2 and pi. And what's kind of surprising is that when you assemble all of those things together, you end up with an object that has no gaps. It's what's called a complete ordered field. And maybe over here we'll add something to indicate we've got rationals too, like -4/3. So that's the idea. This is called an integer because it's a whole number. This guy is called a rational number because it is a ratio of 2 integers. This is called an algebraic irrational, the square root of 2. It's irrational because it can't be written as a fraction with whole numbers. And it's an algebraic irrational because it is the solution to some polynomial equation, namely x squared minus 2 equals 0. And then pi is an example of a number that's called transcendental irrational. So it's irrational, can't be written as a fraction of whole numbers, but it's somehow more irrational than the square root of 2. Not only can it not be written as a fraction of whole numbers, but it also is not the solution to any polynomial equation with integer coefficients. So those are made up of integers, which are whole numbers, rationals, which are fractions of whole numbers, and irrationals, which cannot be written as a fraction of whole numbers. Numbers like the square root of 2 and pi are irrational. And within irrational, you can break those down as algebraic or transcendental, but that's not super important for us in this class. What is important for us in this class is interval notation. So you got to be comfy with intervals. The open interval from A to B is the set of all real numbers bigger than A and smaller than B. And we write, it's denoted like this. On the number line, you might see it written like this, or like this. So it's everything that's strictly between A and B. And there are some fun questions we can ask. Like, does an open interval have a largest element? Is there a biggest number in the open interval 0 to 2? And the answer there is no. You might think you have a candidate. Let's look at an example here. Let's do just what we did. The interval, the open interval 0 to 2 contains lots of numbers. Definitely 1 is in the open interval from 0 to 2. So is 3/2 or 1.5. So is the square root of 2 and 1/2 and 1 over pi. Lots and lots and lots of numbers in that interval. So when I ask my college algebra students, how many numbers are there in the open interval from 0 to 2, a lot of the time I get the answer, there's 1 number in there, right? Just the integer 1. But of course that's not correct, right? Between 0 and 1, there's 1/2, 1/3, 1/4, 1/5, all those fractions. But more than that, there's also irrational numbers like the square root of 2, 1 over the square root of 2, and even some transcendental irrationals like 1 over pi, 1 over e. So there's infinitely many numbers in here. If you want to be a little bit more particular about lots, there's infinitely many. Lots and lots and lots and lots of numbers in that interval. A fun question to ask is there a largest element? And the answer to that question, surprisingly, is no. And we can prove it. So 2's right here. Let's say 0's right here. If you're in this open interval, that means you're somewhere strictly between 0 and 2. So you might think, oh, if I come way over here, maybe this is the biggest guy. But since you're in the interval 0 to 2, the open interval 0 to 2, you have to be smaller than 2, which means there's some distance between 2 and you. And you can always cut that distance in half, and you'll find something larger. So you ask yourself, maybe this is the largest? And the answer is no. Because here's a larger guy, halfway in between the whatever you choose and 2. And you might think, oh, well, maybe this is a good candidate for the largest element. But of course, there's still got to be some distance between him and 2. Otherwise, he wouldn't be a member of this interval. And then you could chop that distance in half. So the answer to this is no. There is no largest element of an open interval. And similarly, no, there isn't. 0 would be a reasonable candidate for the smallest element in 0, 2. But 0's not in the interval 0 to 2. The open interval 0 to 2 is just everything strictly bigger than 0 and strictly smaller than 2. And then as soon as you start looking for a candidate who could be the smallest, you realize, oh, there would have to be some distance between him and 0. I could always chop that distance in half and find a smaller guy. So open intervals are neat. Think of a box, right, in 3D space, like a cardboard box. An open interval is like the air inside the box. It doesn't include the boundary, just the stuff inside. And you can get very, very close to that boundary and still stay inside, but you can't get to the boundary itself. All right, I'm sure everybody has seen interval notation before. The only other thing I want to do is warn you, when you refer to an open interval, tell me that you're talking about an interval. Don't confuse points and open intervals. The notation is the same, right? Parentheses, number, comma, number, close parentheses. It's the same notation that we use for the point x, comma, y, or the point 0, comma, 2. But this is not that point, it's an interval. So let your reader know that you're talking about an interval if there's any doubt. The closed interval from A to B. So the next thing we're going to do is define what it means, what a closed interval is. It's all numbers bigger than or equal to A. And less than or equal to B. And this is denoted by bracket A, comma B. So the closed interval, if the open interval is the air inside the box, then the closed interval is the air inside the box together with the box itself. And you'll see these drawn with either filled in endpoints like this, or with the kind of bracket notation. Like this on the number line. So it's everything in between these guys together with the endpoints. And closed intervals, they do have a largest element and they do have a smallest element. The largest element is always B. And the smallest element is always A. So open intervals, much more complicated, much more interesting than closed intervals in a certain way. All right. Any questions about interval notation or the real line? Get my chat back out. Nope, nothing there. I'm feeling mostly okay. All right. So after getting comfy with the idea of the real numbers as a set and subsets of the real numbers as intervals, next thing we got to be comfy with is the concept of a function. So a function, oh, focus. A function f from a set A to a set B is a rule that matches each object or number in the set A with an object in the set B. And you could say, you should really say with a single or unique object in the set B. In the set, sorry, capital B. So there's some notation for this. In a slightly more grown-up math class, we would write F maps A to B like this. A is called the domain, B is called the codomain, and the elements of B that actually get hit by F are called the range. So the set of all inputs A is called the domain. And the set of all outputs, which is not necessarily B in this notation, is called the range. So I'm sure these are things that you've seen before. And we're just trying to get a little bit more comfy with them as abstract quantities. The graph of a function is the set of all points A comma f of A. So for example, if I have some function that looks like this, so this is y equals f of x. And these are x's. Maybe here I mark 1, 2, 3, 4, 5, 6, something like that. Then the point on the graph right here, I know he has x value 1 because he's right above 1. What's the y value at that point? So right here, I can't say what number the y value is, but I can say for sure that it's f of 1. And this is a big deal. Learning to associate the y values with this function notation. This point would be 2 comma f of 2. This point would be 3 comma f of 3. This point right here above 4 is 4 comma f of 4, and so on. This guy right here, we'll label him, this is 6 comma f of 6. And I might ask you, who's bigger, f of 1 or f of 6? And you would say, well, the number f of 1, that's this y value. The number f of 6, that's this y value. So clearly f of 1 is bigger than f of 6. And those sort of comparisons and getting comfy with the function notation as it relates to graphs, hugely important in this class. So remember, every point on the graph of a function is of the form something, comma, f of that very same thing. So 1 comma f of 1, 2 comma f of 2, 10 comma f of 10. The more comfy you get with this idea, the easier the material later in chapter 2, when we talk about increasing and decreasing, will be. We dive deep into function notation in this class. It's very important that you get very, very comfortable with function notation in this class. That's what will save you through 2/3 or so of this class. So how are we doing on time? We got 15 more minutes. Let's look at a few little problems. We're in 2-2, 2-1. So I'll just grab a couple rando from the textbook here that we can play with for a second, and then I will let you guys go. Yeah. Yeah. Sure, we can do something like this. Okay. Let's let f of x be x squared plus 4. Can we find f of 0, f of 2, f of a plus h, So Lily asked in chat with the homework. Yeah, the homework for a given week will have problems from all of that week's lecture material. So the homework that's going to open today will have some stuff related to what we're talking about right now. It'll also have some stuff that we're going to learn on Wednesday and Friday. And then the grade that week's homework is due the following Monday. So it's topics from the whole week. And you can move around in the homework as much as you like. But I would try to always get it done before the due date, which is the following Monday. So here, f of 0, if we're coming back to this example, f of x, you can think of this as a rule. It says f of anything is what you get by plugging that thing in for x in this formula. So f of 0, and you always want to use parentheses when you do that, is 0 squared plus 4. 0 squared, that's 0 times 0. So 0 times 0 is 0, And 0 plus 4 is 4. Similarly, f of 2 is what you get by coming back to this formula and plugging 2 in here in parentheses. So this will be 2 squared plus 4. Now 2 squared happens to be 4, so that's 4 plus 4, which is 8. And f of a plus h would be a plus h in parentheses, all squared, plus 4. And you want to be careful. This power doesn't distribute. You have to FOIL everything out here. So that would be a squared. That's my firsts. My inners and outers are both a times h, so that's 2ah. And then my lasts, that's h squared. And then I've got my plus 4. So oftentimes I'll ask you to simplify kind of abstract looking things like this. And in order to do that, you just have to remember what this function notation means. F of dog shit would be dog shit squared plus 4. F of anything for this function would be that thing squared plus 4. Places people slip up here are forgetting the parentheses and then forgetting to appropriately apply the algebra rules, like not foiling this, just giving the power to each bit on its own. So this is tame and fast enough that I think we have time to do another problem, and I'd like to look at some piecewise functions. What if I let, you may have seen this before, you may not, f of x be, say, -1 if x is less than or equal to 0, and +1 if x is greater than 0. So this notation with the curly bracket on the left denotes a piecewise function. And it says basically f of x has two formulas. This is like saying f of x is equal to -1 sometimes, and f of x is equal to +1 sometimes. So you can start with the two graphs, y equals -1, and he looks like this. All right, here's your y-axis, here's your x-axis. This is y equals -1. And you can look at the graph y equals +1. That looks like this. So again, here's the x-axis, here's the x-axis. If I wanted a graph of this function, I would say, okay, I'm going to take the y equals -1 graph and just hold on to the parts where x is less than or equal to 0. So that's this piece. And I'll throw this part away. And then I look at the y equals +1 graph. I'm just interested in him when x is greater than 0. That's this piece. And I throw the rest of this away. So if I wanted the graph of this function, here's my y-axis, here's my x-axis. For x's which are less than 0, this function behaves like the constant function -1. And for x's which are strictly greater than 0, so this would be open, he behaves like the function y equals +1. So this is the graph y equals f of x. And in general, this is how you come up with piecewise graphs. You graph each of the pieces on their own, and then you figure out which parts you're going to throw away. So here in the -1 guy, I threw away any x's which didn't satisfy x being less than or equal to 0. That's all the stuff to the right of 0. And here on this guy, I threw away all the stuff that didn't satisfy x is greater than 0. So I threw away anything that had x values less than 0. Putting those together gives me the graph of my function. We could have also deduced this from a table. For example, we could look at f of -1. Since -1 is less than or equal to 0, f of -1 is -1. We could look at f of -1/2. Since -1/2 is less than or equal to 0, f of -1/2 is equal to -1. We could look at f of -3. Since -3 is less than 0, f of -3 is -1. And similarly, you could look at f of 0, f of 1, f of 2. What is f of 0?
-1.
Good. Yeah, because 0 does satisfy 0 is less than or equal to 0. So if I go to plug in x equals 0 here, this tells me I still use this formula. What is f of 2?
One.
Good. Because 2 is greater than 0, I'm using this formula. And similarly, f of 1 is also 1. So piecewise functions, I know, rarely get treated in college algebra. If they do, it's just for a tiny second. And I want to introduce you guys to working with piecewise functions in a gentle way, just through examples like this. Maybe a fun example to leave you on. It's not super relevant, but it's fun. Yeah, so a fun final example, since we talked about real numbers, rationals and irrationals today, is this guy called the Dirichlet function. Dirichlet is a famous mathematician. He had both French and German citizenship, so the Germans like to call him Dirichlet, and the French call him Dirichlet. I won't argue about it, but I call him Dirichlet. This is a piecewise defined function. It's equal to 1 if x is rational, and 0 if x is irrational. That's a weird function. So we can look at a few values. D of negative.
Hey,
Yeah.
sorry, what does it say before the function? Diri something?
Dirichlet. C-H-L-E-T. So D-I-R-I-C-H-L-E-T. Okay, let's try to figure out some values of this function. What is D of -1? So for all these piecewise functions, when we want to plug in a specific x value, we first look over here to figure out whether our x value falls into this group or this group. Is -1 a rational number or an irrational number?
Rational.
It's rational.
Rational.
So since -1 is rational, D of -1 is 1. What about 0? Is 0 rational or irrational?
Rational.
Also rational, so D of 0 is 1. Lainey, yeah, I have not posted this week's homework just yet. That's my first stop after we leave here today. What about D of positive 1?
Rational.
1 is rational, so D of 1 is 1. Okay, what about D of root 2?
0.
0.
D of pi?
0.
0.
D of 1 over pi?
0.
0. Because pi is irrational, 1 over pi has to be irrational. Right? If 1 over pi was rational, then its reciprocal would be a rational expression for pi. And we know pi is irrational. Okay, so I got a few values and start trying to graph this thing. I'll mark this up here as 1. Maybe this over here as -1. So D of -1 is 1. Okay, we're up here. D of 0 is 1. Okay, so we got a point here. D of positive 1, that's also 1. That's up here. Root 2 is like 1.4. So if I mark root 2 as being right here, the y value there is 0. Pi is out here all the way at like 3.1. There's 0 there. But then 3 is like right here. So at 3 is rational. D of 3 should be 1. 1 over pi, that should be about 1/3, right? So that's like right here. And D of 1 over pi is 0. So here we're back down on the x-axis again. This is a strange graph, isn't it? We got some dots up here along the y = 1 line and some dots down here along the y = 0 line. Which one do you think has more dots? So if I check it like 1/2, I know 1/2 is rational, so I should have a dot up here. 1.5 is rational, I should have a dot like here, and lots of dots up here actually. At every rational number, I have a dot up here. Okay, and we know there's a shitload of rationals, right? A shitload of nice fractions. 1/2, 1/3, 1/4, 1/5, 3/4, 10/9, all of those x values will give you a dot up here. But what about the irrationals like pi and root 2 and 1 over pi and e and 1 over e? Every one of those contributes a dot down here. So the graph of this function, this is probably the most exotic graph we're going to look at all semester. You've got a faint sprinkling of dust up here along the y = 1 line, and a sprinkling of dust down here along the y = 0 line. It turns out that the sprinkling of dust down here is a lot more thick than it is up here. There's way more irrational numbers than there are rational numbers. In fact, this guy is almost solid, whereas this guy almost has nothing. But there's still infinitely many dots along both. So this is one of my favorite examples of a piecewise function. It is piecewise constant. And if you look at any particular x value here, there will either be a dot up here or a dot down here, but not both, because this is a function. It must pass the vertical line test. But it's about as discontinuous as a function could possibly be. If you pick any interval and you look just at that interval, you'll find infinitely many dots along the y = 1 line and infinitely many dots along the y = 0 line. It's a very, very strange function. All right, so I think that's a pretty solid little introduction to the real numbers, functions, and the concept of a piecewise function. Starting next time, we're gonna look a lot more at graphs. We're gonna do a bunch of basic graphing stuff. Some of it will be familiar from college algebra, but some of it will be totally new. So make sure you take very careful notes. And then we're gonna start talking about how to get information from the graphs of a function and how to start relating that to inequalities and trying to be a little bit more rigorous about some of the things that you did back in your last algebra class. That is where we are for today. I'm going to go ahead and turn off my screen share unless, are there any questions about this or the last example that we looked at? Anything you guys would like to ask about? That's okay. Yes, so I am recording the lectures. I will be uploading this to YouTube and then posting that link to the same Canvas announcement where you found the meeting link here. However, I have to wait for my computer to process the video, and then I have to wait for it to upload, and then I have to wait for YouTube to process, so it can take a little while. But that will be my next stop. While that is happening, I will prepare your guys' homework and get that available to you. Please do get into webassign today, and at least take a look at the homework before Wednesday. Wednesday, we will talk more about functions, specifically graphing, and we will just move on from there. If you don't have a copy of the syllabus, or if you missed that at the start, please do download a copy of the syllabus and read through it very carefully. It's in a link on the homepage in your Canvas class. And yeah, I think that's it. If you have any questions or concerns, don't hesitate to email or Canvas message me. And I will see you guys on Wednesday.
Thank you.
Yeah, of course.
Thank you.
Okay.
Of course. Yeah, take care, guys.
Thank you.